Hi students, this is the first in a series of videos for the topic of random variables for the International Baccalaureate course Analysis and Approaches. In this video we're going to look at discrete random variables. So a random variable is the possible outcomes that could occur from some random experiment, and we denote the random variable as x or y. A discrete random variable takes distinct possible values, whereas a continuous random variable takes its values in some interval on the number line. All random variables have a corresponding probability distribution. This just states the probability that the variable has a particular value, and it is denoted either as the probability of capital X equals little x or simply as P of x. Here's an example. Let the random variable be the uppermost face of a six-sided die. Then we can say that probability that the 6 is uppermost is 1/6. We could also say the probability that x lies between 3 up to and including 6 is 1/2. Now here's the formal definition. If capital X is a random variable with sample space x1, x2 up to xn, and probability distribution P1, P2 up to Pn, such that the probability that x takes the value xi will be equal to Pi. In other words, these are the probabilities that relate to these outcomes. For I is equal to 1 to n, then all of those probabilities have to lie between 0 and 1. They can be equal to 0 or equal to 1. That's fine. Also, the sum of all of those probabilities must equal 1. Here's an example. For the probability distribution of x, find the probability that x is equal to 2. Well, it's really simple. It's 0.4. What's the probability that x is either equal to 0 or 3? So it's going to be 0.15 plus 0.2. What's the probability that x is not equal to 3? Well, it's going to be 1, take away 0.2. Here's a past exam question. A discrete random variable x has the following probability distribution. Part A, find the value of k. So we know that all of these probabilities added up have to equal 1. So we're just going to do that. And tidying it up, you can either solve that using the quadratic formula or you can stick it into your calculator. But either way, we get two values. K is equal to negative 0.2625 and 0.25. But we know that all of these probabilities, including this one, have to be positive. So K can't be negative. So our answer is K is equal to 0.25. B, write down the probability that x is equal to 2. So it's going to be k over 10. K is 0.25, and so the probability is 0.025. D, find the probability that x is equal to 2 given x is greater than 0. So x is not including 0 there. So we'll use our conditional probability formula, which is the probability that x is equal to 2 and x is greater than 0 divided by the probability that x is greater than 0. So this is just going to be the probability that x is equal to 2. And then the probability that x is greater than 0 will be 1 take away 0.475. And so the answer is 0.0476. Let's move on. The cumulative distribution function capital F of x is the probability that x does not exceed a particular value of little x. So capital F of x is equal to the probability that x is less than or equal to this value. Here's an example. For the probability distribution of x, find the probability that x is less than or equal to 2. So we're going to go 0.15 plus 0.2 plus 0.4, which is equal to 0.75. Let's move on to expectation. The expected outcome or expectation for the random variable x is the mean result, mu. We write e of x is equal to mu, and it is the sum from I is equal to 1 to n of the x value multiplied by its corresponding probability. Here's our first example. What is the expected outcome for a 6-sided die? So we're going to take each of the outcomes, 1 to 6, and multiply them by their corresponding probability. Of course, in each case, the probability is going to be 1/6. So e of x will be 1 times 1/6 plus 2 times 1/6, etc., etc., and it's equal to 3.5. It's a past exam question. A discrete random variable x has the following probability distribution. Find the value of k. So we know that all of these probabilities added up have to equal 1, and x is either going to equal 2, 4, 7, and 10. So we're going to substitute each of those in and then make up an equation like this. So adding those numerators and moving the 15 over here, k is equal to 15 on 23. B, find the expected value of x. So remember, we're going to take each of these x values and multiply them by their corresponding probabilities. Now k was 15 on 23, so I'm going to take that out the front. And we're going to get 15 on 23 multiplied by 2 times 2 on 15 plus 4 times 4 on 15 plus 7 times 7 on 15 plus 10 times 10 on 15. And putting that in the calculator, we get 7.35. Now the expected gain from a gambling game is the expected return less the cost of the game. A game is considered fair if the expected gain is 0. In other words, e of x is equal to 0. Let's look at an example. 2 standard dice are tossed. Let x be the sum of the scores on the 2 dice. Find the probability that x is equal to 6. So here's the score on the first die and the score on the second die. And if we want a total of 6, we can have 5 and 1, 4 and 2, 3 and 3, 2 and 4, 5 and 1. So there are 5 ways out of the 36 that we can get a score of 6. The probability that x is greater than 6 is all of these here. If we add them up, we get 21 out of 36. The probability that x is equal to 7 given x is greater than 6. So x being greater than 6 is all of these ones here. So we're going to have it out of 21. Those that are equal to 7 are these ones here. And there are 6 of them. So the answer is 6 out of 21. Elena plays a game where she tosses 2 dice. If the sum is 6, she wins 3 points. If the sum is greater than 6, she wins 1 point. If the sum is less than 6, she loses k points. Find the value of k for which the game is fair. So we need to work out the expected value. We're going to do 3 times the probability that the sum is 6, plus 1 times the probability that the sum is greater than 6, plus negative k times the probability that the sum is less than 6. And we worked those out in the previous slide. So we have this equation. 3 times 5 on 36 plus 1 times 21 on 36 plus negative k times 10 on 36. And that has to equal 0. Multiplying everything by 36 and tidying up that numerator, we get 15 plus 21 minus 10k is equal to 0. So 10k is equal to 36. K has to be equal to 36 on 10, or 3.6 points. We can also calculate the variance and standard deviation of a discrete random variable. And this is just an indicator of the spread of the data values. Here's the formula. The variance of x is equal to the sum of, we take each x value and subtract the mean, and we square that and multiply by the respective probabilities. Now that's one formula. There is another formula which I actually prefer. Let's expand this out. Now you can see that I have separated it into 3 different sums. Here we have e of x squared, And here I'm going to take the 2 mu out the front, and here I'm going to take the mu squared out the front. Now here we have got e of x, or mu. And here the sum of all the probabilities has to be 1. So we have e of x squared take away 2 mu squared plus mu squared. Here's the alternate formula, e of x squared take away mu squared. And because the standard deviation is just the square root of variance, we can also calculate the standard deviation of a discrete random variable. Let's look at an example. Calculate the variance and standard deviation for the probability distribution shown. Now, as I said, I quite prefer this formula. So I'm going to start by working out e of x. And I'm going to do 0 times 0.15 plus 1 times 0.2 plus 2 times 0.4 plus 3 times 0.2 plus 4 times 0.05, which is 1.8. Now, if I want to work out e of x squared, then I need to square the x value and multiply each by their respective probability. So the variance of x is going to be, there's e of x squared there, take away mu squared, it is 1.16, and the standard deviation is just the square root of that, which is 1.077. You can use the graphics display calculator to calculate variance and standard deviation for a probability distribution. What you do with the TI Inspire is open a spreadsheet, and you enter all your x values into one column and all your probabilities into the next. And I would encourage you to label the first column as x and the second column as p. Then you go to Menu, Stat, Calculations, and you choose one variable statistics, which probably seems a bit strange, but this actually is one variable. This would normally be the frequency column. And you choose one list and enter x for the x1 list and p for the frequency list, and then press OK. So we get our mean, which is 1.8, and we get our standard deviation, which is 1.07703. It doesn't give the variance. You need to square the standard deviation to work out the variance. Now the remaining part of this video is for high-level students, and we're going to be talking about linear transformations. Given the mean and variance of a random variable x, we can calculate properties for a related random variable ax plus b, and we have the following formulas. The expected value of ax plus b is equal to a times the expected value of x plus b. The variance of ax plus b is equal to a squared times the variance of x, and the standard deviation of ax plus b is equal to the absolute value of a times the standard deviation of x. Now, before we look at an example, let's look at the formulas that you get, because there's quite a lot. You get the expected value of a discrete random variable, the variance and standard deviation, and you also get those linear transformations of a single random variable. You also get these two formulas for variance. So here's an example. The mean for the random variable p of x is 1.8 and the variance is 1.16. Calculate the mean and variance for y, which is equal to 2x minus 3. So from our formula booklet, the expected value of 2x minus 3 is 2 times the expected value of x, take away 3, which is 0.6. And the variance is going to be 2 squared times the variance of x, which is 4.64. And let's finish off with a past exam question. In a city, the number of passengers x who ride in a taxi has the following probability distribution. After the opening of a new highway that charges a toll, a taxi company introduces a charge for passengers who use the highway. The charge is $2.40 per taxi plus $1.20 per passenger. Let T represent the amount in dollars that is charged by the taxi company per ride. Part A, find E of T. So we can see that T is a linear transformation of x, and x is the number of passengers, so T is going to be equal to $1.20 times x plus $2.40. Now, using our formula up here, E of t will equal a times E of x plus b. But we need to figure out what E of x is. And it is 1.59 passengers. So substituting into our formula, E of t is $4.31. B, given that the variance of x is 0.8419, find the variance of t. So again, using our formula, we're going to get the variance of t is equal to a squared times the variance of x. A, remember, is $1.20, and in the calculator, our variance is 1.21. Okay, that's it for discrete random variables. In our next video, we're going to look at the binomial distribution.